Hello, my name is Chuta Sano, and I would like to present a joint work with Stephanie Balzer and Frank Fenning. Our paper is titled Manifestly Phased Communication by Shared Session Types. First, I'd like to introduce linear session types, also known as binary session types, to distinguish them from multi-party session types. When we have two concurrently executing processes and we want them to communicate, we can actually type their channel of communication. And since Honda's seminal paper, there have been many additional works that expand on linear session types, but one line in particular establishes a Curry-Howard style correspondence between linear session types and linear logic. One approach by Kirish and Fenning uses intuitionistic linear logic, and the other by Wadler uses classical linear logic. In this talk, we will work with the intuitionistic approach. And in that setting, the two endpoints of a linear channel are given either the client role or the provider role, and they have dual interpretations of a given session type. For example, this is a ternary external choice where the client must pick and send one of three labels, B, C, or D. The provider would then receive one of those labels, and the two would continue according to the type associated with the label. So, for example, if the client sends the label D, then the two would continue as DL. One direction of research allows us to type communication involving one provider and multiple clients. In this example, we have two clients who communicate with a shared provider, and we can safely do this by introducing a shared layer of session types, which can only be constructed by these up arrows from L to S. In this setting, clients must attempt to acquire exclusive access to the provider, whereas the provider must only accept one of them. For example, if C1 successfully gets chosen, the two would communicate linearly according to BL, but note that C2 will be blocked, since it is still attempting to acquire. After some series of linear communications, the two will eventually encounter a down arrow from S to L, and note the content of BS, it must itself be an up arrow, right? The down arrow, by the way, signifies a point of release, and the client will release its exclusive access to the provider, returning the session to the original shared state. And at this point, P can, for example, accept the request from C2, which will have the two communicate linearly. We can also view the session types and their progression as DFAs, where transition occurs due to a sending or receiving of a message. For example, if we take the previous shared type and interpret it from the client's perspective, we would say that after a successful acquire, the type would transition to BL, and then after some series of linear messages, we eventually encounter a down arrow, and after release, we're back to the initial up arrow type. We can collapse this DFA to a single state, where the sequence of messages beginning with an acquire and ending with a release is what we would call an acquire-release cycle. In the original formulation, shared session types were required to be equisynchronizing, which intuitively means that after an acquire-release cycle, the session type must return to its original point to prevent type mismatch with other clients attempting to acquire. We found that this restriction on the release point is a bit too strong and prevents the encoding of phases, which encode the progression of shared session types across successive acquire-release cycles. So in this diagram, we can see that there are three phases, AS, BS, and CS, and we show possible transitions between these three different states, which the equisynchronizing constraint would forbid. So the question is, how can we represent phases at the type level? In this work, we successfully solve this in a safe manner. That is, we maintain the same meta theorems such as progress and preservation while relaxing this constraint on releases. Now, to be a bit more low level, and I'd like to work with an auction protocol as our flagship example. This type is a bit involved, and we'll spend some time later working through the protocol step by step. But the big picture point that I want to emphasize is that this is a shared session type because we see the initial up arrow, and moreover, you can see that it is equisynchronizing because after every down arrow or release, we go back to the auction type. The unique provider will serve as the auctioneer, and the clients will be the participants of a series of auctions. Now let's walk through a fragment of the protocol. So I'm going to present a scenario with one provider and two clients. And if we expand out the types, we get an up arrow. So client 1, client 2 tries to acquire, provider accepts only one of them. It accepts client 1. Now the two communicate linearly. So we first encounter an external choice. The client 1 would then send bid, as an example. And the provider now has to pick between, okay, you can bid, or no, you shouldn't bid, you're supposed to be collecting. So suppose the provider says, okay. In that case, the client 1 would send its ID, an abstract type. It would send money, some other abstract type, and then we're back to this down arrow where client 1 and provider have to release. At this point, they're both back to a shared state, and the provider can accept a connection from client 2 and continue linearly. Let's revisit this big auction type again. We can actually see a notion of phasing that we would like to enforce. For example, if the client sends a bid over here, and the provider says, no, we're in the collecting phase, we would actually want that client, the next time it successfully acquires, we want the client to actually send collect. As with the current state, there's nothing preventing the client from being stupid and sending bid again. And similarly, if the client sends collect and it receives a prize because it won the auction, it would not collect again. You would want it to bid next time it acquires. We can summarize this idea into a two-state DFA, where we conceptually would like to have a bid state, which requires the client to only send bid, and the collect state, which requires the client to only send collect. The client would then transition between these two phases according to a particular sequence of messages starting from an acquire and ending with a release. But we omit most of them except for the important label messages on branches for presentation purposes. For example, if we're at the bid state, so the client sends bid, and then the provider says, no, we're collecting, well, we'd like the client to transition to the collect state, and so on. And as a first approach, we look at subtyping, which was first worked out for linear session types by Gay and Hull. And the idea is that provider and client can safely communicate with each other if the provider views the channel as a subtype of whatever the client views it as. And the subtyping rules here are standard. We can support subtyping with the new shared connectives in the most trivial manner. If the continuation type is a subtype, then the arrow type is a subtype, and so on for the other type. So now we seem to be moving at the right direction. The provider is still using this big auction type, but the clients now use the types bidding and collecting, which are both super types of auction. The key point is that bidding can only send bid, whereas collecting can only send collect, and the release points reflect the transitions between phases that we informally presented previously. So now let's go through a fragment of this protocol where both client 1 and 2 are in the collecting phase. So as per usual, we begin with acquire, provider accepts, and at this point we see that client 1 can only send this collect label, which is fine. It sends the collect label which the provider can accept, and then they continue talking linearly. Eventually, they encounter this down arrow, where client 1 is required to release at bidding, and the provider is required to release at auction. And that's fine. Client 1 is now bidding, provider is now auction, and the provider can still communicate with client 2 because it can accept both bid and collect after an acquire. So if it accepts a connection from client 2, it would all work out. Now I want to illustrate one subtle problem with this setup, which requires me to introduce the typing judgment of a client process. The part to focus on are to the left-hand side of the turnstile. The first context consists of gamma and AS, which is a structural context with shared channels. And the next context is delta, a linear context with linear channels. So if we step through the protocol, after an acquire and accept, the client would have this linear channel, which corresponds to the continuation type after a successful acquire. They would then proceed linearly, and eventually the client would have this linear channel, which requires it to release back to bidding. And after it does so, it now has AS as type bidding, which is what we precisely want. However, let's take a little step back. there's nothing preventing the client from aliasing this AS of type collecting to some other name, and then performing this release step, and now holding a reference of type bidding and collecting. So what have we done? Well, because gamma is a structural context, or at a more higher level, shared channels can be aliased, malicious clients can store and reuse references to previously known phases. So we haven't really enforced phases. We've only suggested phases at this current point. And now to fix this, we introduce LL shifts. So I want to summarize the grammar of our session types. And the key point are these arrows. These are the arrows that we introduce at the shared layer, and the rest are fairly standard. And we also add in these two new shifts. These are down and up shifts from L to L. And the key point is that they're both linear. And when we introduce this connective, we have to add additional subtyping rules. And these two are the simple rules. They say that, well, if the continuations are subtypes, then the arrow types themselves are subtypes. However, the more interesting rule are the following two. We say that if the continuation types are subtypes, then an up from L to S is a subtype of an up to L to L. And similar idea for this down arrow. Now, something I want to point out is that this type is a shared session type, whereas this type is a linear session type. So what we've really done is we're allowing the provider to view a type as some shared type, whereas we force the client to actually view it as a linear type. And in fact, that actually solves the entire problem. We can still confirm that auction is indeed a subtype of bidding and collecting, but now the clients view the session types as linear types, as you can see by these arrows. What we've done is we've replaced the LS and SL shifts by the appropriate LL shifts. And at this point, this forbids the client from making any sorts of moves regarding aliasing or using any backups because they're linear, and linear channels forbid aliasing because it rejects contraction. So to summarize, we were able to show the formalism to allow phases to manifest at the type level, and that further increases the expressivity of shared session types. One of the most interesting points from a theoretical perspective is our use of subtyping. The instance of shared to linear subtyping that we propose allows us to bridge different modalities, and moreover, it allows us to naturally use different modalities to solve the second problem which we demonstrated, that shared channels can be aliased. One potentially unsatisfying aspect of our result is that we almost exclusively focus on techniques that apply to clients, but we hope to continue this path to also include the provider in the big picture. Another interesting item is that there have been recent papers that propose subtyping for multi-party session types, and although at a surface level we can see some parallels between the subtyping that we work with and their subtyping, it is not really clear at the moment how to precisely compare the two approaches. And I think one of the reasons blocking this comparisons is that we do not have a precise relationship between binary session types and multi-party session types, in the sense that we cannot yet encode MPST in the binary settings at the type level, but preliminary results do show that we can actually use the techniques that we introduce here to encode multi-party types in the binary setting at the type level. One final thing I would like to mention is that, as we expect, this talk is a summary of our paper submission for Coordination 21. But actually that submission is itself a summary of a more involved technical report, which consists of a full formulation of the type system we present and proofs of the usual progress and preservation theorems. Thank you very much.